Question 3. A student heated a solid sample of NaCO3, that's sodium carbonate, XH2O. It means it's got waters in this substance. It's probably crystals. So it's got crystals with water in, but we're not sure how many waters, and that's what the X is for. And that's what you've got to try and determine. How many waters, how many XH2O, what is the value of X? How many waters in these crystals? And what they've done is they've taken a mass, the mass of the empty evaporating basin, the evaporating dish. They've got the mass of the evaporating dish plus the sodium carbonate with the waters in the crystals. And then they've heated it up for 1 minute to remove the water, and the mass has come down because the water has been removed. Use the data in the table to calculate X for the formula NaCO3 XH2O. Give your answer to 2 decimal places. So we've got to find X. So first of all, your first job is to find out how much of this solid Na2CO3 XH2O, how much of the solid sample has been put into the evaporating dish. Well, we know the mass of the empty evaporating dish. We know the mass of the evaporating dish with the solid in it, so you subtract those two. 25.47, take away 24.35, so the mass of the sodium carbonate Na2CO3 XH2O is 1.12 kilograms. Therefore, if you know the mass of this, once you've taken the water out, you can work out the water. So this is the mass of the solid sample before you've heated it, and after heating it, it's gone down to 24.92. Subtract those two, and you've got 0.55 grams of water. Now, if you know the mass of all of the solid sample, you know the mass of the water. If you subtract these two away, you'll work out the mass of the Na2CO3 on its own. So I've got the mass of the whole of the sample, 1.12, the mass of the water, 0.55, subtracted those two to work out the mass of the sodium carbonate that would be there without the water. Okay, so now then, I've got to work it out in moles. I need to work out the ratio. Now I've got Na2CO3, and now I've got XH2O, and I know how much XH2O I've got. I know how much Na2CO3, but it's in grams. I need it in moles so I can work out molar ratios and work out this X. So the MR of Na2CO3, and Na is 23, a carbons are 12, 3/16 for the oxygen, 106 moles is mass divided by MR. Mass of Na2CO3 is 0.57 divided by 106. I've got 0.0054 moles. Similarly for the water, MR is 1 plus 1 for the hydrogens, for the H is plus 16 for 1 oxygen, is 18 moles is mass, 0.55 for the water divided by 18, 0.0306 moles. So the ratio of the sodium carbonate in moles to the ratio of water is 0.0054 to 0.0306. If I divide by the smallest to get a better ratio, the smaller number there is the 0.0054, so divide both by 0.0054 and the ratio is 1 to 5.682. So for every 1 Na2CO3 I've got 5.682 waters. So X is 5.682. So for every 1 NaCO3 I've got 5.682 waters. It wants its 2 decimal places, so round it up to 5.68. The correct value is 10, quite a long way out. Suggest a reason for the difference between the experimental value and the correct value. Well, what I'm not happy is, how do we know that after 1 minute all of the water has been removed? Surely you'd carry on heating it until this value didn't go down anymore, and then you'd know that all the water had been removed. Just by heating it for 1 minute, it doesn't necessarily mean that all the water has been removed. You'd carry on heating and heating and keep taking the mass until the mass didn't go down anymore, and then you'd know that, that all the water had been removed. So the problem might be that you didn't remove all the water. A suggestion: heat for longer until the mass no longer changed, and therefore you'd know that all the water had been removed.